Hey, good morning, everybody. Welcome to your PlayPosit for the week. Go ahead and grab your notes and have that OMHS PlayPosit graded assignment open, and we'll get started. I hope you saw that my note for today. While you're getting your PlayPosit a little later than usual, it is going to be very short today. One quick reminder, don't forget that we have that math event for you guys this Tuesday, so that is tomorrow from 1:30 to 2:30. The link is on your daily plan and the passcode is VAVA 2020. If you guys can't find it, feel free to email me in the moment and I can always send you the link, but that's there for you. And then don't forget about your extra credit opportunity for Black History Month. This is in your course under content and extra credit. So the assignment's there. You can just go click on that link. It'll bring you to this screen and you'll click continue without signing in and then just complete the activity within Desmos. Don't worry, you don't have to submit anything. You don't have to email me anything. Desmos auto saves. So once you get to the last slide and you've completed all the questions, then you finished the assignment. So that is due by this Friday. So we're just going to finish up things on basically on the formula sheet. And there are a few questions that we did not get to last class. So these notes are in that packet from last class. Here it says the volume of a cube is 8 centimeters cubed. What is the surface area? So all we have is this one single number. And then it wants the surface area. So let me pull up our formula sheet. Actually, I have it here. Nope. Hold on, I'm going to pull up our formula sheet for you guys. And this is also going to be good practice so you can remember how to find it. If you haven't found it yet, I strongly recommend that you go into your OMHS like I'm doing now, get that formula sheet and print it so you can have it near your workstation and ready to go because you're allowed to use it the whole year and on your SOL. You want to get comfortable using it so you're not kind of surprised when you see it in May. All right, here's the, oops, this is algebra. We are in geometry. Algebra has its own formula sheet. You definitely don't want the algebra formula sheet. It will not help you very much. So we're going to go to content, and then along the left-hand side, course materials. And here is the formula sheet. It's a PDF document, so you can just open it up and save it to your computer or print it. All right, volume of a cube. So we're looking for a cube. Here it is. All right, so volume is length times width times height. So that's all we were given. So that's what we're going to start with. Volume equals length times width times height, which is 8, right? Okay, and then we want to find the surface area. And if you go back to your formula sheet, you'll see that the surface area is 2 times the length and the width plus 2 times the length and the height plus 2 times the width and the height. So you're multiplying all those different combinations by 2 and then adding them together. And that's because of the number of sides a cube has. So if we know that the entire volume is 8, how could we find each of these measures? The only 3 numbers I know that multiply together to give you 8 is 2. You got to kind of think, well, what could I multiply together to give me 8? 3 times. I suppose we could deal with some fractions as well, but I know that 2 times 2 times 2 is 8. So there we go. Let's plug in what we know now. We know that the length and the width and the height are 2, so everything is 2. 2's for everyone. So we end up getting 8 plus 8 plus 8. 24 centimeters squared. So the good thing about this problem is I wanted to show you that sometimes you're only given one single number, one single value, and you have to sort of work your way through the problem to figure out the other question that they're asking. All right, here's another one. The height of a cylinder is 9.5 centimeters. The diameter is 1.5 centimeters longer than the height. What is the closest volume of the cylinder? So the diameter is 1.5 centimeters longer. This word longer, that should sort of make you think of a certain operation, right? Addition. So if the height's 9.5, the diameter is going to be 1.5 longer. So we're going to add 1.5 to that. So that is 11, right? The diameter is 11 centimeters. So the volume of a cylinder, again, you'll just go to your formula sheet. You'll find the cylinder shape. There's no pictures on here, so sometimes it does help to draw a picture. Here's that cylinder shape. I am not a three-dimensional artist by any means. And let's see, the height is 9.5. And we know the diameter is 11. Remember, the diameter is the length all the way across that circle from edge to edge through the center. So the volume is pi r squared h. So in the formula, we actually need the radius. So if the diameter is 11, what's the radius? Remember, it's half of that. So the radius is going to be 5.5. 5.5 squared times the height is 9.5. So take a peek at these answer choices and look, they all have pi in them. It's a good idea to sort of look ahead and see that first so you guys don't do some unnecessary calculations there. We want to leave pi in the answer. So I'm going to grab my calculator. 5.5 squared is 30.25 times 9.5 is 287.375 pi centimeters cubed, since we're talking about volume. So I'm just going to go find the one that is closest to that. And sure enough, it is B. I'm wondering, what is 287 times pi? 287 times pi is 901. I was wondering if they were going to try to throw in one of those values to try to throw you off if you had accidentally multiplied by pi. But they did not. Just be careful again to look ahead at those answer choices and choose the best one, and don't multiply by pi if they did not. All right, this is the last one from last class. Sarah is filling a glass sphere with decorative sand. The radius of the sphere is 2 inches. So this time they give you the little formula sheet here. There's the sphere. The radius is 2 inches, which is the closest to the minimum amount of sand Sarah needs to completely fill the glass sphere. So we're talking about filling it. When you look at the formulas underneath the sphere, which one is going to give us information about filling the sphere? And that's going to be the volume, right? When you fill something with water or sand or air or rocks, you're talking about the volume that it holds inside. The surface area is that word S, surface, and it tips it off. It's on the outside of the shape. Like if you were to take wrapping paper and cover the outside of this ball, or paint, that would be the surface area. So we're looking for volume, 4/3 pi r cubed. And they give it to us about radius. The radius is 2, so we just need to plug in 2 and go ahead and solve. Now this one does not have pi in the answer choices. And you know what? It doesn't tell you what to use for pi. So that means you can kind of do whatever you want. You can use 3.14 by like typing it in the calculator as 3.14, or you can use the pi button. You're going to get slightly different answers, but one of them should still match up because those are all very different, A, B, and C. Let's see. So I'm getting 32 divided by 3. So all these numbers here, 4/3 times 2 cubed is 10.66. I'm not going to round it off because I want to get as many decimals in my answer as possible until the end, right? Because I want to go ahead and multiply by pi now. And I'm going to use 3.14 at first, and that gave me 33.49. And then I'm curious, if I did not use 3.14 and I used the pi button, and then someone also said you can actually just type pi, which is so nice, it's like a shortcut, you get 33.51. So see, they're very close, but they are different values. So if for some reason, you know, you were having to do like a fill in the blank or something, it should tell you what to use for pi because they're not the same answers. And we can write inches cubed, or they here have cubic inches. That's another way to write that. Just like with area, squared inches, or inches squared. So our answer is the closest here is the 33.5. All right, now we're going to look at some comparing problems. So this first one tells us there's a triangle with an area of 3 millimeters squared. And then we dilate this triangle by a factor of 6. Remember dilation. So this is not drawn to scale, but I have a triangle and I'm going to dilate it. I'm going to make it bigger or smaller depending on the factor, right? How does this change the area? I mean, you would think if you're going to dilate, so 6 is bigger than, it's not a fraction, right? So it's going to get bigger. So our area should get bigger because we're going to dilate each of these side lengths by 6. I'm going to show you how to do that. So we're talking about area. So area of a triangle is 1/2 base times height. Again, you'll just grab that right off your formula sheet. And it tells us that is 3 millimeters squared. So when we do dilation, if you remember back to the days of dilation and translation and all of those different transformations, dilation affects every side length of the shape. So we're going to change each side of this triangle by a factor of 6. And factor, all we do is multiply. So we have 2 side lengths here in our formula. So we're going to multiply the base by 6, and we're going to multiply the height by 6. Because that's going to change the shape by a factor of 6. If this also had like any other side lengths in the formula, you would just multiply any side length by that factor. So we're going to change this entire formula shape by a factor of 36. We're multiplying 6 times 6. So we need to multiply the whole thing by this factor. So we don't really need to know what these side lengths are or what these measurements are because we already have the area. So the area of the dilated shape is the area of the old shape times the dilation, the total dilation. We have to take into account all the sides that are used in that formula. And each of them are changing by 6. So we're going to multiply by 36. So the new area is 108 millimeters squared, which makes sense, right? 108 got bigger. It's bigger than 3. So we're going to do some more, don't worry. You'll see hopefully the pattern here. And don't forget you can pause the recordings at any time. So this time they want us to use a rectangle with an area of 5/8 feet squared. That's a tiny rectangle. So that's what we know. We know it's a rectangle. So go to your formula sheet, find the area of a rectangle, and that's length times width, which you probably already know that. And that is 5/8 feet squared. It's so tiny. And we're going to dilate it by a factor of 8. Again, this is going to make it bigger. It's not a fraction. So this formula, again, has 2 side lengths of that shape in it. It has the length and the width. So we're going to change each of those by a factor of 8. So we're changing the entire formula by a factor of 64. So all you do is take that and multiply it by the given area. because if you multiply each side length by that, but we don't know the sides. If we knew the sides, we could just do that math, and we could find the sides in this one very easily. You could solve for length and width and then just multiply each side by 8. You could do it that way. Or I guess this is sort of a shortcut. Or if you don't know or you can't easily figure out the side length, you're just multiplying the whole thing by that scale factor per side that's used in the formula. All right, so this is not an x. Sorry, don't get confused there. I should probably just write it like this. And this gets you 40 feet squared. You type that in your calculator. You would do 5 times 64, hit enter, and then divide by 8. Or you could do it by hand and reduce, right? 8 into 8 is 1, and 8 into 64 is 8. 5 times 8 is 40. There you go. That shape changed greatly. It went from having an area of 5/8 to now having an area of 40. It expanded. All right, two more very similar. A prism with a base area of 3 meters squared and a height. Okay, so base area is 3 meters squared, height is 4 meters, and we're going to dilate by a factor of 3/2. What is the volume? So I'm going to grab my volume formula. Remember, big B is a special number, and it's the area of the base. Let's see, where's my, oh yeah, it's 450, right? That's what they, hold on, am I looking at the wrong problem? Oh yeah, so funny. Okay, let me erase that. I have the other problem on my brain because I did work all these out already. Okay, there we go. Okay, so the base area is 3 meters squared. Oh, I don't have my pencil. The height is 4. What is the volume of the dilated prism? So this is not the right formula then. And hopefully you guys caught that as you're looking at your formula sheets. Okay, I'm actually going to bring in the formulas for us over here. Just 1 second. I think this will be helpful. There we go. All right, this is our prism. These are the two prisms we have. Well, that's more of the cube. Here's our prism. So we are going to use that formula, B times H. Remember, big B is the base. And the base of this prism is a triangle. So the area, base area, is area of a triangle. So 1/2 base times height is that 3. And then we also have, it tells us the height of 4. So we sort of have these, and I know that you see it in H here, but that's included in the formula to find the base. This big B, okay, this is the H here. So we do have to take it into account sort of twice there. So we're going to multiply our scale factor, the dilation of 3/2 by every single side length that's going to be used. And there are 3, here, here, and here, because they're all used in this volume formula. Remember, the big B has its own H, and then the volume formula has its own H. So we're going to multiply everything by, let's see, 3 times 3 times 3, that's 27, and 2 times 2 times 2 is 8. This is our sort of combined dilation or scale factor that we're going to multiply everything by. So now it says, what is the volume of the dilated prism? Okay, well, big B is 3, that's what they told us. And H is 4. So we get 12. So in this one, we had to go ahead and figure out the original volume. The original volume is 12. Remember in the other two, they gave it to us. Here we just had to figure it out. And then go ahead and multiply it by the combined scale factor. That's 27 over 8. So our answer, which I'll put up here, is 40.5 meters cubed. So that one was definitely a little bit different and had an extra step there in finding the original. And then also, don't let it trip you up about these sort of double H's here. You do have to account for it twice. All right, last one. A prism with a volume of 450 feet cubed. So again, the volume of that prism is big B times H, which is 450. We're going to dilate it by a factor of 2. But remember, all the side lengths that are used in the formula. So big B is 1/2 base times height, and then we have the height again. So we're going to have to multiply again by that factor 3 times, because we're using 3 of those side lengths in that formula. So by 8. So this time they gave us the original, and we just have to multiply everything by 8. And it's very big. 3,600 feet cubed. So in your OMHS, you guys are finishing up all of the formula sheet work, a lot of volume and surface area and things like that. So as you're working through that, if you have any questions, always feel free to reach out or come to office hours on Tuesday. A lot of it you're seeing is just being able to identify the right formula, what to plug in. Sometimes you need to find things like a radius from a diameter and things like that. And then this whole scale factor stuff. So I will see you guys on Thursday. Have a great week until then. Bye, everybody.